Hello, good day everyone there. My name is Jefferson Agogobia Jarwe. This is my maths channel, mathematics channel. In this video, we'll be looking at some special things in mathematics. Please do help me to subscribe on my YouTube channel, like, comment, as well as help to share other groups. It might be of good help. Please help me do this. And besides, I also want comment from you. So the area that I'm not typically doing well, please let me know so that I can, correct such, improve on such areas. In this class, we typically going to look at a linear equation. So that's what we're going to look at today. We're going to look at what? Linear equation. Linear equation. Now, the word linear simply means straight line. Now, a linear equation is an equation in which the highest power of the unknown is 1. Now, the fact stems from the fact that if different solutions, let's say we have different solutions from different linear equation of the form y is equals to ax plus b. If we have different pair, let's say different pair x1 y1, then we have another pair x2 y2 up to xn yn, different pairs of this equation, if they are actually plotted on our Cartesian plane, that is on our graph, the kind of a graph they are going to generate is typically of the straight line graph. So the fact stems from the fact that the linear equations stem from the fact that if this form of equations are plotted on our Cartesian plane, and our Cartesian plane is of this nature, we have, this is your y axis, and here is positive. You have your x axis, and here is this is positive as well. Then we have, this is the 0, this is the origin of our Cartesian plane. So right here, down here, we have the y-axis as well, y-axis, which is negative, and the x-axis, which is negative. So from here this way they are positive, from here this way they are what? Negative. So I'm trying to explain why we term it as linear equation. So in an equation in which if we generate two pairs, that is our coordinates x1, y1, s2, y2 to sn, yn, if they are plotted on this our Cartesian plane, this is the kind of graph you're going to give us, a straight line graph. So it's going to be y is equal to ax plus b. So that is, the graph of this nature will be obtained if the coefficient of x here, which is the unknown, is positive. So we can also obtain another type of graph of this nature, y is equal to minus ax plus b. So if the coefficient of x is negative, your graph will tend to what? Will slope downward, like that of the demand curve. So if the coefficient of x is positive, you take the what? The nature of the supply curve. So we are not looking at economics here. I'm just trying to explain why do we refer to this kind of equation as linear, because if different solutions from this set of equations are obtained, or they are plotted on the graph on our Cartesian plane, this is the kind of graph we're going to obtain. That is why we term it as what? Linear equation. Yes. Then other names for linear equation. Other names. Other names for linear equation. Simple one. Simple equation, or sometimes we also call it open sentence. So at the kindergarten level, you will hear like open sentence. It's the same thing as linear equation or simple equation. Then in this class, we're going to look, how do we find out that an equation is linear? So we're going to look at that. An equation is said to be linear if one, the highest power of the unknown term is 1. 2, if the solution has one set of value. So for this time we have here, this is y is equal to ax plus b. Now in this equation, y is equal to ax plus b. The unknown term here is x. Now any moment that the highest power of x in an equation, or the highest power of what you are trying to look for in an equation, is the highest power is 1, such an equation is referred to as what? A linear equation, because the highest power or the unknown, what you are looking for, is 1. This is the first condition that make an equation a linear equation. Then 2, in this kind of equation, we just have one value for x. So if we are solving for x, we're going to have just one set of value, one solution, one answer to it. That's why we refer to it as linear equation. So these are the two conditions that make an equation to be linear, or make an equation to be simple equation or an open sentence. So long that the term you are trying to look for in the equation, if the highest power is 1, such an equation is known as a linear equation. So now let me rewrite this one very well. This is y is equal to ax plus b. So in this equation, or let me simply put it in this way, we have ax plus b is equals to what? Y. Here, this x here is, in this equation, is the unknown, what we are trying to look at, the unknown. So here, we call it, this is unknown term. We call it the unknown what? Unknown term. So that's what you are trying to look for. Then the a here attached to the unknown term, we call it what? Coefficient. Refer to it as what? The coefficient of the unknown term. The coefficient of the unknown term. Now, why this b and the y here, they both together are known as what? They are known as the constant what? Term in the equations. So that is how you identify a linear equation. So if you look at the highest power of the unknown here is 1. So the moment that the highest power of an unknown in an equation is 1, such an equation is referred to as a linear equation. So I've given you a definition. An equation is said to be linear if 1, the highest power of the unknown term is what? It's 1. Then 2, solution, if the solution has one set of value. So if the solution has what? Set of value. Then, before we move further, let's now define what do you understand? What do you understand by equation? What do you understand by what? Equations. Now, in mathematics, equations are statements showing that two mathematical expressions are the same or equal. So the simple definition of equations, whether it is linear equations, quadratic equations, cubic equations, quartic equations, is say that for an equation, the meaning of equations is that they are statements that shows that two mathematical expressions are the same, or two quantities are what? They are the same. That is the simple definition of what? Equations. Now, there is a term that surfaces here. We say expressions. What? Expressions. So then, what are expressions? What are expressions? So we have to look at the meaning of expressions first. Then, in mathematics, expressions are mere mathematical statements. They are mere what? Mathematical statements devoid of the equality sign. Devoid of what? Of the equality signs. Okay. So expressions are, they are just mere mathematical statement that's devoid of the equality sign. So for us to to understand this much better, let me express this in a tabular form. We have expression A, expression A. I have another expression B. Then the next thing is what? Equation. So in a tabular form, so we're going to see the relationship between equations and expressions. So we have to know this. These are the basics. So if we have y here, this is one expression. We have ax plus b. For us to obtain an equation from an expression, what we need to do is just for us to insert. For us to do what is insert any of the inequality signs. So for us to obtain an equation from this is y equal to ax plus b. The moment we insert an equal to sign or any of the inequality sign into two expressions, they become an expression. We must know this. So expressions are the basis of what? Equations. Without expression, there will be no equations. So let's take note of that. That is example 1 here. Then number 2, we have something like this: ax plus b, and another expression cs plus d. So for us to obtain an equation from these two expressions, what we need to do is just to insert any of the equality sign here. So we have, this is ax plus b is equals to cs plus d. So this is how equations are formed. They are expression give birth. Expressions give birth to equations. So example 3, we have x over b. Here we have let's say c. Yeah, so for us to form an equation from this, we say x over b is equals to c. This is how equations are formed from expressions. So let's take note of this. It's very key. So we are going bit by bit. So the next aspect we're going to look at is we're going to understand the following terms here. This time we're going to understand the following term. We're going to explain the meaning, the unknown term. The unknown what? Terms. And 2, coefficients. Coefficient, then constants. On IV we have a side of an equation, and then 5, solution of an equation. So we must know all this. Quickly, from our expressions, from our equation, which says that y is equal to ax plus b. Now, the unknown term is the value of either any of the alphabets. It could be a symbol that we are looking for in an equation. So if we have, for instance, we have 6x is equals to 12. Here, the x here is the unknown term. So in any equation, the variables, the unknown variable, the unknown value is referred to as the unknown term. So that's the meaning of the unknown term. Then let's look at the meaning of coefficient. So the unknown term is that term in which we are here to determine in an equation. Then coefficient. So in mathematics, a coefficient is any numerical value attached to an unknown variable, or any numerical value that multiplies an unknown variable. That's the meaning of coefficient. So in this place we have y is equals to ax plus b. So the coefficient, the a here is the coefficient of x, because the a multiply x. That is the simple definition of coefficient. Is any numerical value that what? That multiplies the unknown in an expression or in an equation. Okay, then constants. In mathematics, constants, they are fixed numerical values that do not tend to change at a specific time. So if we look at this place, our constant, like I mentioned the other time, our constants in this equation are y, and what? B. They are the constant. They are what? They are the constant because their values are usually supplied here. So then sides of an equations. An equations at least has two sides. An equation usually has what? At least two sides. Then if you look at these equations, we will have what we call this is the right hand side, and on this side before the equality sign is called what? The left hand side. So an equation has two sides, the left hand side and the right hand side. Okay, then finally 5, solution of an equation. Now when you say the solution of an equation, the solution of an equation is the value of the unknown term that you will eventually resolve, that we satisfy the equation. That is the solution of an equation. So by the time you find the value of x, the numerical value of x, or any unknown term in an equation, that value, that numerical value, is usually the solution to the equation. So we must understand these concepts because we need them even as we make progress. I hope I'm well understood. Okay, let's move on. Having explained all these terms, let's now move forward. Okay. Okay, another area we're going to look at in this mathematics class, we're going to look at an aspect of number theories. It will enable us to resolve our linear equation with less difficulty. So we're going to look at one aspect of number theory that has to do with what we call additive inverse, and secondly, 2, multiplicative inverse. So these two aspects will enable us to resolve problems on linear equation with less difficulty. So what arises here is the idea of using collective items will be avoided using these two aspects of number theory. So additive inverse. So what is additive inverse? The additive inverse of a number is usually obtained by multiplying the number by -1. By what? -1. Okay, this is just a definition. Okay, let me explain using our numbers line. Okay, we have our number line. We have 0 here. This 0 is our reference point. To your right, everything they are positive. So assuming we want to find the additive inverse of a number, say 4. 4 is positive. With this number line, let's use it to explain it. Let's be more pragmatic here. So from here, everything here, from here down, they are positive. So here down, they are all negatives. Then for us to obtain the additive inverse of +4, what you need to do, you just say, you come here and write what? -4. That means you have multiplied it by what? -1. Then if we have, for instance, -b/a, then what will be the additive inverse of -b/a? So if you just come to this side, it becomes what? b/a. over what? Over A. So the number involved, you just multiply it by -1, that is all. If it is minus, change it to plus, that will be the additive inverse. And one of the properties of additive inverse is that if a given number, for every given number, the sum of the number and its additive inverse must give you 0. So, like for instance, I said 4. The additive inverse of 4 is -4. So -4 plus 4, that will give us what? 0. So we have minus b over a plus b over a is equals to what? 0. So that is one of the properties of additive inverse. You must take note of this, very key. Okay, we need it. We need it. By the time we look at it, we will understand it much more better. Okay, then that is for additive inverse. Then the multiplicative inverse. Let's look at multiplicative inverse. Now, another name for multiplicative inverse is called reciprocal. It's called what? Reciprocal. So another name for multiplicative inverse is reciprocal. It's called what? It's reciprocal. Reciprocal. That is another name for it. So now I want to explain this very briefly. So if we're looking for the multiplicative inverse of any number, if we have 4 as a number, the multiplicative inverse of any number is usually obtained by using 1 to divide the number. Using 1 to do what? Divide the number. So this one means 1 divided by what? Divided by 4. So it will be 1 over 4. That's a simple explanation of multiplicative inverse. Or let me put it simply, it means by inverting the number, making your denominator to become numerator and numerator to become what? Denominator. So that's meaning. So this 4 now simply means 4 over 1. So the reciprocal means you write this in place of this and this in place of this. So let's take note of that. The reciprocal of any number or the multiplicative inverse of the number is obtained by what? Inverting the number. So, and one of the property of multiplicative inverse is that a number, the product of a number and its multiplicative inverse, it usually give us 1. So if we have 4 as a number, like I said the other time, and we said that the reciprocal is 1 over 4, let's look for the product. Product means times. 4 times 1 over 4, and that will give us 1. So that's one of the properties of reciprocal or multiplicative inverse. Is that understood? So, for instance, take note. For instance, we have b over a. The multiplicative inverse will be what? Okay, if we have a over b, the multiplicative inverse will be b over what? A. And if we say a over b times b over a, our answer will usually give us 1. That's one of the property of multiplicative inverse. So this aspect will enable us to do so many things in the application of linear equation. Please take note of it. Okay. Now let's quickly look at different forms. forms of linear equation. Forms of what? Linear equations or simple equations. So we have different forms. One, we have the one of this nature: ax plus b is equal to c. So we have a linear equation of this nature. Ax plus b is equal to c. And we also have two, the one of this nature: ax plus b is equal to cx plus d. So example for this, let me give example for this. We have, let's say, 6x plus 5 is equals to, let's say, 12. Okay, no, let's say 11. So the one of this nature, we can have something like the of this nature, 3x minus 6 is equals to 4x plus 8. This another of this form. We can also have the one of this nation, x over a is equals to b. So for this one we have x over 2 is equals to 1 over 4. So this nature. So these are the different, we have so many of them, but you know, we are going to take them in a piecemeal, bit by bit. So in this class, we will probably look at this one. In this video, we'll look at this. Imagine you come across a linear equation of this form. How do you resolve it? So there are so many of them, they are countless. I just mentioned this one. In our next class, we look at more, give more example on how to resolve them. So quickly, let's look at the step that we require. The step we require to solve linear equations. Step what? Step involves. Look at this. Step involved in solving linear equation of the form ax plus b is equals to c. So I'm going to put the step one by one. Step 1. Identify